All right, so what we're going to be looking at now in this video is we're going to be looking at a hypothesis test for the mean. We're going to be looking at a z-test, a z-interval, a z-test. And the method we're going to use is the p-value method. So on the exam, what you'll be given is you'll actually be given the p-value since you're not going to have to compute it. So what we need to be able to do is we need to be able to use that p-value in comparison to the significance level in order to actually tell us the result of our test. So again, we're going to be thinking, well, what do I want to do? I want to figure out whether I'm going to reject or fail to reject the null hypothesis. So first, I'm going to figure out what my null hypothesis is, my H naught. Okay? So if I look, you're an environmentalist interested in the prevalence of acid rain as measured by the pH of the rainwater in the northeastern United States. Assume that the mean normal pH for pure rain falling through clean air is 5.7. You randomly collect and test 39 samples of rainwater in the northeastern United States and calculate a sample mean pH of 5.5 with a known population standard deviation of 0.6. Okay? Using this data, test the claim that northeastern rainfall is more acidic than it should be. That is, that the mean pH is lower than the normal value of 5.7. And then using technology, you get the following data, p equals 0.017. Test using, I'm going to write this as alpha equal to 0.05. So now my H naught is going to be this 5.7 because that is the normal pH for pure rain falling through clean air is 5.7. So mu equals 5.7. Okay? HA, my alternative then, is going to be this information. It's lower than the normal value of 5.7. So mu is less than 5.7. Okay? So those are my null and my alternative hypothesis. This, by the way, if we want to kind of think about it, this is going to be a left tail test, right? Because it's going to be the less than. So I want to figure out if I'm going to reject or fail to reject the null hypothesis. So the information I'm given is that P, before I do that, all right, I do want to understand, as just a review, that we're going to be using the z-test because I have the population standard deviation, right? So sigma equals 0.6, so I will use the z-test, okay? Just in case you're asked which test you should run. Totally going to happen. Or in case you want to know which one should I run. You're going to run a z-test because you have the population standard deviation and you're looking for the mean. Okay? So now I'm going to figure out what my p-value is. I'm told that p is equal to 0.0187. And then I'm going to compare that to alpha. Alpha equals 0.05. All right? So p is less than alpha. Okay? And hence reject the null hypothesis. Just take a look. P is 0.0187. Alpha is 0.05. P is less than alpha. We're going to reject the null. There it is. Fabulous. That's wonderful, right? So simple. Now, what that means is there is sufficient evidence right, to reject the claim that the mean pH is, and this is very important, is our 5.7. That's our null hypothesis. There is also sufficient evidence to support the claim that the mean pH is less than 5.7. Okay? Because that's our alternative. So we can support the alternative because we actually rejected the null. We rejected the null. Why? Because p was less than alpha. Just to help us picture this, okay, we've got my distribution. All right, here's my one with alpha. Alpha over here is 0.05. That's how big alpha is. Okay, and I have my mu equal to 5.7 in the middle. Conversely, my p-value one, p, here's my picture, okay? Here's mu equals 5.7. I have over here, I actually have my test statistic. Excuse me, it's actually probably farther over here. I have my test statistic, okay, which was my x bar equal to 5.5. And the size of this region in here, the size of that region was the size of 0.0187, right? So consequently, the probability of getting an X bar or a sample of, in this case, 39, um, a sample of 39 samplings of rainwater to have a pH less than 5.5 would be 0.0187. So consequently, this size, smaller than that one, right? Okay. Those two, we look at them. This one's bigger. How do we tell that using the numbers? We're just going to go through and compare P and alpha. P is one of them, alpha is a different one. Since P is less than alpha, we'll reject the null. And that's it.